A very good morning to all the participants. I welcome you all to this 1 week online FDP on harnessing virtual labs for effective student engagement. Today is our final day of the FDP, and we have had our team from NIT K Surathkal who have led us into various disciplines on how you can use these virtual labs for effective student engagement. Today's session is even much more exciting. And why do I say that? Because today we'll be looking at how you can actually create one of the labs on your own. Because if you think some of the experiments are missing from your concerned departments or concerned disciplines, you can actually take the initiative and then you can create a virtual lab for yourself and in collaboration with the team. So that is one thing that we'll be looking at, and that session would be led by Mrs. Anusha from NIT K Surathkal. And we'll also followed by which we'll have even much more exciting session, which is immersive experiential learning through virtual reality. And this will be led by Mr. Sumant. Both are from Virtual Labs Development and Outreach team for the Center for System Design at NIT K Surathkal. So before I give this time to them, I just want to make a quick announcement that today we'll be having a valedictory session at 12 p.m. 12 p.m. will be a valedictory session. And during the valedictory session, we'll be having the feedback link. The overall feedback link will be shared during that time. I request all the participants to please be there and attend the sessions. And you will have more announcements regarding the when we are going to give the certificates and all those things. So please join us for this valedictory session at 12 p.m. followed by after all these sessions. So without wasting much time, I would like to hand over this time to the team at NIT K Surathkal. Over to you, sir, ma'am. Shrestha ma'am, Anusha ma'am, are you there?
Yes, sir.
Yes.
Sir. So, good morning, all. So, myself, Shrestha. I, on behalf of Virtual Labs team at NIT K Surathkal, welcome all the participants for today's session as well. So, today, as told by Daniel, sir, we'll have session on VLab development, virtual reality based topic, and also, if possible, we'll see 1 or 2 labs from mechanical engineering, which participants had asked yesterday. So we'll try to accommodate that as in today's session before the valedictory. So with this, without much wasting time, I'll hand over the session to Anusha, who will be taking you with the concepts on VLab development. So thank you.
Thank you, Shrestha. Good morning, everyone. Myself, Anusha Salyan, from the Virtual Lab Development team at Center for System Design and NIT K Surathkal. I will be walking you through the development procedure of VLab. I hope my voice is clearly audible.
Yes, ma'am. Yes, ma'am, your voice is clear.
I hope my screen is also visible.
Yes, ma'am, it's visible.
So over the past few days, you have been exploring different virtual labs from various domains. So in today's session, I will give you a brief overview of how virtual labs are developed and the technologies used in the development process. This will help you understand the steps involved in creating virtual labs and how they work. So before starting the virtual lab development process, it is important to first determine what type of lab needs to be created. This includes identifying the subject area or the domain, such as physics, chemistry, biology, engineering, or computer science. Once the domain is selected, the next step is to decide on the specific experiments that will be included in the virtual lab. These experiments should align with the learning objectives and help the students understand the key concepts effectively. Proper planning at this stage ensures that the virtual lab is relevant, engaging, and useful for the learners. So to create a useful virtual lab, it is important to identify areas where a lab is not yet available or where there is a need for new topics. This could include subjects that are currently trending or experiments that have not been covered on the portal. To find these gaps, the developer or the proposer must thoroughly explore the existing labs and experiments in the virtual lab portal. By analyzing what is already available, one can determine which new labs or the experiments should be developed to enhance learning opportunity and fill the missing areas. For instance, in the last sessions, some faculty members have requested demonstration of virtual labs that align with subjects being taught in their curriculum. However, some labs are not yet available on the portal. So this gives an opportunity to identify these gaps and take the initiative to develop new virtual labs. By addressing these missing areas, can enhance the available resources, support effective teaching, and improve the overall learning experience for students. So, I hope my screen is visible.
Yes, ma'am.
Thank you, sir. So these are the broad areas of virtual lab covered. There are 9 different domains of labs covered in this list. So you can identify, you can explore different broad areas. You have been exploring since the last few days. But to develop, you have to go through all the streams thoroughly. And for example, if we take an example of computer science and engineering lab, there are few labs missing. For example, big data or only one or two labs related to AI technologies and data science, etc., are available. So you can take this as a gap area and start developing the lab for these topics. So this is an example. So going back to the presentation, I hope you have understood this. Now we'll move on to the next slide, which provides an instruction to today's session on virtual lab development. So creating virtual lab experiments requires making them interactive so that the user can engage with them easily. One of the biggest challenges is adding animation to the simulation that keeps user interested. To ensure the best experience, a well-organized process is followed while developing and hosting these labs. The development process includes 6 stages of review from round 0 to round 5 before the final version is made available on the community portal. So each round must go through multiple stages of the review process, and all the review steps play an important role in shaping the lab into a complete learning system. And every phase focuses phase or rounds focuses on specific improvements and it ensures that the lab meets high quality standards. So the lab development committee oversees all these process. So this committee includes experts from top institutes such as IIT Bombay, IIT Delhi, and other participating institutes, including NITK Surathkal. So the committee carefully tests the content of each lab to make sure it is accurate, interactive, and effective for learning. Before a lab can move to the next stage, it must pass strict quality checks. These reviews help to identify any issues and improve the overall functionality of the lab or the experiments. The goal is to provide a reliable and engaging learning experience for students and educators. By following this structured approach, virtual labs are developed with high precision and effectiveness. The step-by-step review process ensures that users receive high-quality virtual experiments that enhance their learning in an interactive and engaging way. So in the development process, first step is round 0, which is the brief overview. And in round 1, which describes pedagogy, and round 2 is about storyboard, round 3 and round 4 is about development simulation and the content for an experiment or lab, and round 5 is approval from the reviewers or the LDC committee and deployment. So this is the overall development process. Okay. So before starting the development of a new virtual lab, it must be proposed by filling out a proposal form. So that is done in round 0 step. This the proposal form is provided by the central team of Virtual Lab Initiative. The proposal serves as an official request to create a new lab and ensures that it aligns with the educational objectives, curriculum needs, and technological feasibility. The proposer must carefully provide details about the lab to justify its necessity and relevance. So, what are the key elements covered in round 0? So the key elements covered in round 0 includes lab overview, broad objectives, outcomes, experiment list, target group, purpose, and software technologies. So what should be covered under these elements? So in broad objective, a general statement explaining the purpose of the lab, its significance, and what it aims to achieve should be covered under the broad objective. So round 0, all the steps in the development process has a predefined template. So in the round 0, broad objectives, purpose, target group, etc. Should be covered in are covered in that template itself. So under purpose, the specific reasons for developing the lab, such as addressing gaps in existing virtual labs, supporting a particular subject area, or improving the learning outcomes must be covered. And in the expected outcome, the learning goals and the skills that students will gain by using the virtual lab should be covered in the expected outcome. And in target audience, identifying the group of users who will benefit from the lab, such as undergraduate students, postgraduate students, or professionals in a specific field. So under software technologies, listing the software tools and programming languages that will be used to develop and run the virtual lab. This includes simulation software, programming frameworks, or web-based platforms. So we'll be discussing about the software and the technologies used in the in this session later. Now, we'll see the last key elements of round 0, that is experiment list, a detailed outline of the experiments that will be included in the lab, ensuring they align with the learning objectives and the curriculum requirements. So, as per new protocol by the Central Virtual Lab team, a lab must consist of 10 experiments, minimum of 10 experiments. So, every lab must have 10 experiments. So all those things, all these key elements you can see in virtual lab under introduction, list of experiment, target audience, course alignment, etc. In this field, the same contents can be found. So what is the importance of round 0? Round 0 is essential because it helps in planning and structuring the virtual lab effectively before proceeding to the next development stages. The review panel evaluates the feasibility and clarity of the proposed lab before approving it for further development. So this is about round 0. So in the development, next stage is round 1. And at this stage, each experiment within the lab must have its own separate documentation. As I said, a lab must consist of 10 experiments from round 1 onwards. Each and every experiment in our lab should be documented in a separate documentation form. So the learning objectives and the pedagogical approach for each experiment should be clearly defined to ensure effective instructions and alignment with the educational goals. If you are proposing 10 experiments, each experiment's pedagogy must be documented separately using designated template provided. So in this step, focus area, learning objective and cognitive level, instructional strategy, task and assessment questions, and the simulator interaction for experiments need to be clearly defined. So we'll see what are these one by one. So pedagogy or the round 1 describes focus area, learning objective, cognitive level, instructional strategy, task and assessment questions, and simulator interaction. So what is this focus area? So focus area refers to the key objective or main emphasis of a virtual lab experiment. Or in simple words, we can say what the experiment focuses on. So in virtual labs are designed to cover different learning approaches. It can be practical based, theoretical based, measurement based, etc. The focus area can be practical experiments or laboratory based experiments or theoretical concepts. So these are the two different learning approaches. There are several learning approaches covered in virtual lab. If you explore, you can observe that. So the practical experiment. So these kind of experiments or lab focuses on hands-on simulation, where users perform virtual experiments similar to those conducted in physical lab. The emphasis on the experimental procedures, observation, data analysis, and real-time simulation of the lab environments. So the theoretical concepts labs are designed to help the students understand the fundamental principles and theories through interactive visualization, animations, and conceptual demonstration. The focus here is on enhancing the conceptual clarity rather than conducting experimental procedure. For example, to give example for practical experiments, some of the labs developed by NITK Surathkal under civil engineering are practical based or laboratory based. For example, marine structure, strength of materials, environmental engineering, etc. In this lab focuses on the procedure followed in the conventional lab. Same procedure followed in the physical laboratory is simulated in virtual mode. To give the example for theoretical concept, um, the lab developed by NITK again, that is mechanics of machine or machine dynamics and vibration and dynamics of machine lab, engineering graphics lab. So these labs are based on the theoretical concepts. The students or the user can understand the theory concept from these labs. So yeah, practical experiments and theoretical concepts serves as different educational purpose. So they are the so their focus areas are different. So this is about focus area. Next is learning objective. So learning objective defines the scope and the structure of a simulation, ensuring that all the goals set by the proposer are met in each experiment. An experiment can have multiple learning objectives associated with cognitive level and an action verb to specify the expected learning outcome. So the learning objective means what the students will learn by performing the experiment, or what are the things they will understand, whether the calculation, analysis part, demonstration, etc. So next is instructional strategy, which refers to the approach or the method used to guide users through the simulation effectively. It helps in determining how the experiment will be conducted, ensuring clarity and engagement. The chosen strategies depends on the complexity of the experiments and the target audience. So the next is task and assessments. The purpose of interactive simulation is to enhance students' learning by engaging them in hands-on tasks. These tasks are designed based on the learning objective of the experiment, which is previously defined, ensuring alignment with educational goals. Various types of assessment methods are used to evaluate the user's knowledge before or after performing the simulation. There are two types of assessment methods, that is formative and summative. So summative means what are the questions available under the pre-test and post-test sections. These are summative questions. And formative questions, if you have observed in civil engineering labs developed by NITK Surathkal, during the simulation, while performing the simulation, some questions will be popped up. So such questions are formative, which means they are used to make the simulator more interactive. Okay. So this is about task and assessment question. The next key elements of round 1 is simulator interaction. So this section outlines how students engage with the simulation and how the system responds. It details the specific tasks students will perform, such as inputting values, adjusting parameters, or conducting experiments. Additionally, it explains how the simulator reacts to these actions, such as displaying results, providing feedback, or guiding the user through the steps. The purpose of these tasks is to ensure that students actively participate in the learning process, reinforcing the key concepts and improving understanding through the hands-on experience. So this is about round 1. So all these key elements should be described for all the experiments. Okay, now we'll move on to the round 2. So in round 2 of virtual lab development, the focus is on creating a structured narrative for the experiment through a story, storyboard, and mind map. So what is the story for an experiment? The story serves as a comprehensive document containing all the essential details related to the experiment. It outlines the visual elements to be incorporated into the simulator, such as text, images, story, buttons, input buttons, and interactive components, etc. Additionally, the story defines the user objectives and goals, ensuring that the experiment aligns with the intended learning outcomes. So another critical aspect is the pathway activities, which describes how the user will have to navigate through the experiment, detailing each step of interaction within the simulation. Furthermore, the story includes equations, formulas necessary for the simulation, ensuring accuracy in calculation and scientific relevances. In case of labs or the experiments related to computer science, the story should include the flow chart and the algorithm covered in that particular experiment or experiment. By developing a well-structured storyboard, and mind map, developers create a clear blueprint for the virtual lab, streamlining the design and implementation process while enhancing user engagement and learning effectiveness. So this is about the story. So story contains all the information pertaining to an experiment and the key points covered for an experiment. So now let us see what is storyboard. A storyboard is a graphic organizer that visually represents the step-by-step process of an experiment through a sequence of illustrations or images. So the storyboard serves as a blueprint for the simulation, outlining the pathway or the procedure followed by the user during the experiment. And in storyboard, each and every step is depicted in a picture-by-picture format, making it easier to understand the flow of interactions within the simulation. And the storyboard helps the developers design an intuitive and user-friendly interface. So storyboard is a graphic organizer in the form of illustrations or the images displayed in sequence. On the other hand, a mind map is a visual representation of all the key concepts of an experiment, including main concepts and their sub-concepts. So it helps to organize ideas in a structured manner, showing how different elements of the experiments are connected with each other. By using mind map, developers can ensure that all the necessary topics are covered, making the experiment more comprehensive and aligned with the learning objectives. Together, the storyboard and the mind map provides a clear visual framework for designing an effective and engaging virtual lab simulation. So this is an example for mind map for one of the experiment developed by N.T.K. Suratkal, that is slump test, which comes under marine structure lab. This is the lab. So the mind map is for this particular experiment, slump test. Okay. So now we have reached the conclusion of the documentation phase in the virtual lab development process. Next, we'll move to the simulation development, that is round 3. So before that, you might be wondering why the development process begins with round 0, round 1, and round 2. So these steps or these initial rounds serves as a foundation for building a simulation that enhances user understanding of the topic. Additionally, they act as an essential documentation for the lab developer, ensuring a structured approach to content creation. This process also helps in developing material similar to a traditional lab manual, making the virtual lab more comprehensive and user-friendly. So these documentation part helps the developer or the coder to develop the simulation in a better way. That if the coder or the developer is from non-technical background or the lab is from the core background, it may be from circuit or mechanical domain, then a developer or the coder should understand what he or she needs to be simulated. So this documentation serves as a manual for the coder. Okay. Next, we'll move to the round 3. Development of a simulation of an experiment begins at this stage. So there are 2 steps involved in the development cycle of a simulation of an experiment, that is content development and simulation development. So again, content development and simulation development can be further divided into subphases. So content development and simulation development steps ensures that the virtual experiment is not only interactive, but also aligns with the educational objectives and provides a comprehensive learning experience. So the content development phase of virtual lab development focuses on creating instructional material that serves as a foundation for the experiment, which includes content development for a lab and content development for an experiment. So in content development for a lab, introduction, objective, list of experiments, target audience, course alignments are included. And in content development for experiments in a lab, aim, theory, pretest, procedure, post-test references are covered. So you have observed in virtual lab the template. So all these contents or the sections are covered in virtual lab. So again, the theory, a detailed explanation of the scientific or the technical principles underlying the experiment are covered in theory. In the procedure, a step-by-step guide on how the experiment should be conducted, pretest and post-test, initial the assessment to assess the user's prior knowledge before performing the experiment, and post-test is an evaluation conducted after the experiment to measure learning outcomes. And in the references, the supporting materials or the additional materials such as research papers or textbooks to provide additional information, or the materials used for developing the simulation are covered under the references. So these details should be gathered in the content development phase. And yeah, so the next phase is simulation development. In the simulation development phase, this focuses on designing the interactive experiment based on real world data and laboratory practices. So this includes gathering data, results and observation, and visual elements. So data such as lab procedures, formulas, expected outcomes, algorithm flow chart, etc. And results and observation, structuring the simulation to provide accurate experimental results, and integrating images, graphs, and interactive components to enhance user engagement. So this step primarily focuses on building the simulation. Okay. So this is about the content development part. Now we'll see the protocols and the rules to develop the simulation. Simulation has to be designed in such a way that it should achieve all the objectives, goals, and pathways set in the previous rounds. That is, the learning objectives set in the round 1 must be achieved in the simulation part. So in simulator, for developing a simulator, only free and open source tools must be used. Using free and open source tools ensures cost effectiveness, accessibility, and flexibility in virtual lab development. And it allows wider collaboration, promotes transparency, and enables developers to customize and improve simulations without licensing and restrictions. Additionally, free and open source tools enhance scalability and ensures that educational resources remain freely available to the users. So what is the advantages of using free and open source tools. So this eliminates the need for expensive software license, reducing the overall cost of development. Educational institutions and researchers can develop and deploy the virtual labs without financial constraints, making high quality educational accessible to all. Since open source tools are freely available, they allow students, educators, and the developers from all backgrounds to access and contribute to virtual lab development. This promotes um, inclusivity and democratizes learning opportunities, especially for institutions with limited resources. So what are the languages or the technologies used for development of simulation? That is HTML, JavaScript, and CSS. Additionally, we can make use of jQuery and JSON. But other than these, PHP, React.js, and other libraries of JavaScripts are not allowed. Using HTML, JavaScript, and CSS for developing a virtual lab simulation provides a lightweight, flexible, and scalable solution that works across multiple platforms and devices. This is about the technologies or the languages used for developing the simulation. We'll move further. So some of the guidelines or rules for developing the simulation, that the simulator must be browser compatible and there should not be any dependency or any additional softwares to be downloaded to run the simulator. So, cross-browser compatibility. A website or a web application or simulations ability to function consistently and correctly across different web browsers and devices. Since each browser interprets web technologies, HTML, CSS, and interprets web technologies, HTML, CSS, and JavaScript differently, ensuring that a virtual lab simulation or a web-based application works uniformly across all the major browsers such as Google Chrome, Mozilla Firefox, Safari, Microsoft Edge, and others is essential for a seamless user experience. So cross-browser compatibility is essential for ensuring a consistent, accessible, and engaging user experience in web-based virtual labs. By making the simulation compatible across various browsers and devices, developers enhance usability, reduce maintenance efforts, and future-proof the platform for evaluating web technologies. What are the advantages of cross-browser compatibility? So it ensures consistent user experience, increases the accessibility and reach, improves usability and engagement, reduces technical issues and maintenance cost, enhances performance and speed, supports future scalability, boosts the search engines and web standards. So, um, cross-browser compatibility ensures that users have a uniform and reliable experiences regardless of which browser or device they use. This is a crucial for virtual lab as inconsistencies in UI design, user interface design, or functionality could lead to confusion or hinder learning. Not all the users have access to the same browser or devices. Ensuring compatibility across multiple browsers widens the audience by allowing users on different platforms such as Windows, Mac OS, Linux, and mobile devices to access the virtual lab without any issues. When a web-based application works seamlessly across different browsers, user can navigate and interact with the content effortlessly, leading to higher engagement and satisfaction. This is particularly important for educational platforms where usability directly impacts the learning outcomes. So a cross-browser compatible virtual lab reduces the number of bugs, glitches, and rendering issues, leading to lower maintenance costs and fewer user complaints. developers don't have to create a separate versions for different browsers, saving time and effort in troubleshooting and updates. And optimizing a virtual lab for multiple browsers ensures efficient performance and faster loading times. This prevents delays or slowed interaction, which can frustrate users and negatively affect their learning experience. And talking about the scalability by the browser compatibility, as new browsers and updates are released, a browser compatible system is more adaptable and future-proof. It ensures that virtual lab will continue to function correctly even as web technologies evolve. Search engines prioritize websites that provide a consistent experience across different browsers, ensuring compatibility improves search engine rankings, making the virtual app more discoverable. Additionally, adherence to web standards ensures long-term usability. So, non-dependency on educational software to run the simulator. Developing a web-based simulator eliminates the need for users to install additional software or plugins, making the virtual lab experience more accessible, efficient, and user-friendly. Web-based simulators can support unlimited users without requiring additional software purchases or installation, and also reduces security risk. So this is about the rules and regulation followed for simulation development, and also about round 3. Now we will move to the last stages, that is round 4 and round 5. So in this steps primarily focuses on content development and the hosting of lab portal for initial reviewing and testing. During this phase, all the essential components of each experiment, including theory, procedure, pretest, post-test, and references, are carefully documented using a standardized template provided by the virtual lab team. And at the end of round 4, the lab simulator goes for the review check or for the review. So there will be a committee of different PICs in which there will be a domain expert from that particular background who will review the contents or the simulation of an experiment, and they will provide the uh, suggestions or modifications or any corrections, errors in the simulator. We have to work on that, and again, it has to be sent back to the reviewers for the check. So this is about round 4, and in round 5, if the lab is approved or passes all the quality checks by the development committee or the domain experts, then it will be approved for hosting in the central portal, that is virtual lab site. So these are about the rounds followed in simulation in virtual lab development. So I hope you all have understood about this. Thank you for giving me an opportunity to talk about virtual lab development. And this is from my end. Thank you, everyone. I will, if there is
Yeah, thank you, Anusha, ma'am. I hope my voice is audible.
Yeah, your voice is audible, Suman.
Okay,
Thank
I'll
you,
share.
everyone. This is now we have come to the end of virtual lab development process. Now we'll move on to the VR learning session. So thank you, everyone. Over to you, Sumant.
I'll just start sharing my screen. Okay, I hope my screen is visible.
Not at yeah, visible, Sumant.
Okay. So immersive experiential learning. So which is nothing but here we are solutions for VLab. It's an extension of VLab actually. So what is virtual reality? It is nothing but a computer generated environment which is totally artificial. We can see the environment in 360 basically, which also comes in 3D, which makes us immersive to that environment. And the key components are HMD, which means head-mounted displays, which is nothing but VR headsets. We primarily require an VR headset, and which contains tracking sensors and controllers, basically to control the environment inside the headsets. So basically, immersive means we completely immerse in it. The basic idea of virtual reality is we are gathering all human senses like uh, the visuals, the audio, hearing ability, and yeah, basically primarily we are covering those two. And one more is touch sensing, which we can get through haptics to the controllers. The combination of three will create a illusion that we are inside the environment. So that is VR, which is completely artificial, a completely virtual world. There is no engagement with the real world in the sense. So let's see what is the difference, primary difference in traditional VLab and immersive VR learning experiences. So basically in traditional VLab, which we have seen right before, so it's a 3D interactional panel where we are doing all the experiments in basically in screens. So some of the limitations are it's a limited perspective. We cannot see in different direction and angles. Well, it's a great way to actually learn in a quick through, but when it comes to immersiveness, it has some limitations. So we are taking those limitations as a problem statement and covering those covering to the solution part using that limitations. So in VR, we can get a 360 surround experience, has the realistic simulations, which means we can interact like how we uh, interact in real world. Interactions are make us tricks our brain that is like we are actually interacting with the environment. So some of the basic principles of VR technology are visual rendering, which means like I said before, uh, creating realistic visuals will help enhance the realism or immersiveness in VR environment. So we can achieve that using these softwares, which is Unity and Unreal Engine. Both are free to use to develop any kind of VR environment, and it's easy actually nowadays to actually develop basic environments in these softwares. And next is tracking. Tracking means we have like just having a VR 3D immersive experience isn't enough. So we have to track it has to track our movement just like in the real world. So the HMD's head-mounted displays requires those sensors like it should track our position and orientation, how our head is tilted or moving. So those are some of the essentials which are required, and the sensors will act on it. And next is haptics to get that realistic feedback when we touch or grab something in VR environment. So that will create a realistic interactions. And the latency, delay in action and response. So let's say, for an example, I'm grabbing a specimen in an VLab simulation. So it has to be so real, like latency should be so minimum that it should feel like real. The response should be instant, so that there shouldn't be any lag. So in through VR, we can get a 3D experience such that we can get a enhanced spatial understanding and students' engagement will be more in this type of environment platforms. And we are visual learners mostly. Humans are prone to more visuals, so that will capture their attention and it will increase their motivation to learn. And things they will learn will have more attention period compared to the theoretical learning. So this is a survey conducted after the VR sessions we conduct in NITK. So we have different lab experiments for different domain engineering students, and majority of students reported they have improved their understanding of the concepts. So some of the advantages of VR, like we already covered, like we are covering the real world applications, and we are actually learning through performing the experiment through just like how we actually perform in the real world. And it's a personalized learning, adapts to individual styles, which means and the best case is we can configure it in any way. Like a student doesn't need a teacher in this type of environments. He can self-guide and self-learn through performing different types of trial and errors. It is scalable and accessible and can be deployed to many students anytime. And safe experimentation. Yeah, the one of the major advantages, it eliminates the risk and reduces the cost. In the sense, let's say some complicated chemistry experiment. So, so there are much harmful hazardous chemicals. So the student can trial and error with different types of experiment. There is no personal damage or any equipment damage. So we can reduce those type of uh, risks. And some of the disadvantages and challenges of VR, which we have currently, is the initial investment is for the hardware is high. Um, so basically, there are two types of headsets which you can get to see uh, in the current market. One is the cardboard, which is nothing but smartphone-based VR experience. Smartphone in the sense you have to place your smartphone on a cardboard type of device. So our smartphone is capable enough to actually have all those sensors, like to track the position, movement, head movements. So we can design such project for this cardboard type of devices. So where we lack is the inputs. So the inputs are mostly minimum compared to the much expensive devices. And technical issues, like there are glitches, and motion sickness is one of the major concerns and disadvantage, which means uh, like it's something similar to trying to read a book in a moving vehicle. So that is motion sickness. So when you wear a headset and you try to move in the virtual world without physically moving, you'll experience that. So there are different types of movement interactions, which we need to uh, uh, focus while developing these type of experiences in solutions. And accessibility to ensure all it is accessible to all students with different disabilities, like voice access, voice commands, or text commands, and the quality of the contents should be instructional design. Uh, and this is the one of the main thing which we need to focus while developing these experiments, which is user guided, like instructions. So this is the future of engineering. So we can expect the VLabs to be converted in VR labs in upcoming future, which is a new method of learning complex concepts. It's already in action here in NITK Surathkal. Uh, we are giving experience to different domain students to perform their course curriculums. where they can revise their concepts in a much immersive way. Okay, now I will show some of the experiments which we have developed here in CSD. Okay, this is a ISO UTM, Universal Testing Machine experiments. You can see the hand in there. This is actually running in MetaQuest 3. It's a VR headset. It's a commercially available, and here we have given hand interaction instead of the controllers. So basically the HMD itself has some camera and sensors which will track our hand movements. So using that, we are performing the experiment. Here he will navigate through. I'll just teleport. So while developing, we have considered all types of least count measurements for the vernier calipers, the dimensions. Okay, so now he's trying to navigate. So this is the one of the disadvantage while using hand tracking. So yes, now we'll perform the experiment. He's applying the load. He's through the gauge now. Okay. One of the disadvantages of hand tracking is it's not consistent. Like it continuously need to track the hands. So the best approach is always to have a controller or some adaptive gloves. So this is a strength of material lab for isode impact experiment. It's an under development. It's in under development. So here in this case is actually using the controller for the interaction. So now we try to move continuously. So this is one of the bad implementation which you just saw, which is continuous movement. So he's moving using his controller, just navigating, pointing out. So these are some of this will cause motion sickness. So the best approach is which you have seen earlier, which is teleportation. Okay, we'll apply. He'll pick it and place it. So that he'll try next trials from there on. So let's see some other experiments. Okay, this is the same one. So this one is for the same UTM machine. This is one of the most realistic thing we have developed. This was developed using Unreal Engine, and the previous ones are all from the Unity software. He'll get instructions, what needs to be performed. The graph is being generated and the values will display. So that was about immersive experiential learning. I'll show some of the softwares or which you can use to develop these type of experiments. I hope my screen is visible.
Yes, sir.
Okay. So this is called Unity. So basically we need game engines to design these type of environments. And the best part of Unity is basically all the whatever software I'm going to show you will be free to use. For the ones who have lower end of systems, like who have low configuration systems, can go with the Unity software because this is the most easy to approach, and there are more learning tutorials over here. Like you can cover the essentials, programming, VR development, and AR. You can just get started with the templates over there. So that is one advantage of Unity over Unreal Engine. So in case of Unreal Engine, it gives you more realistic visuals, which is harder to get in Unity software. Both are free to use, but Unity is preferred over Unreal for most majority of people. So any questions? Okay. I hope I can hand over the session to Prajwal now. Is Prajwal there? I'll just inform him.
Yes, Prajwal is there. But maybe before his session, we can have queries from the participants, if any, on VLab development and session on VR. So it is open for the participants now. They can type their queries in the chat box.
Okay, ma'am, Prajwal is not able to actually unmute himself and share the screen. So he needs to give an host access.
I think now Prajwal will be able to share his screen. So participants, if there are any queries regarding the previous two sessions, you can type in the chat box so that our team will answer your queries. So meanwhile, Prajwal will take you through demonstration on 3D printing lab experiments. So that was one of the query yesterday.
Hello.
Yes, sir.
So Prajwal will be presenting from my system.
Okay, okay, ma'am.
Yeah. So now we'll look into experiments from 3D printing lab. So sharing the screen.
Okay, so good morning, everyone. My name is Prajwal, working in the part of our virtual lab development team. So, as one of the students had asked about the doubt in 3D printing, so we'll be exploring about that 3D. So, we have the different broad areas of virtual lab. So, under that, click on that mechanical engineering. So, in that first experiment is there, which was developed by one of the university, that is the Albert. Is okay. So, we'll be exploring about 3D printing virtual simulation lab. Click on that. So as you can see, in 3D printing, so these are the subsets. So what exactly the 3D printing in the introduction part it has given. So 3D printing is also called as additive manufacturing. The process of making the 3D objects from a digital file. Like the creation of 3D printing object is achieved by using a additive process. Like we have many different 3D printing in our lab as well. So we are having a MakerBoard replicator 3D printer. We have also we have HP Jet Fusion 580 3D printer. We have so yeah. So we'll learn about the what is the objectives, like why we go for a 3D printing. So 3D printing enables you to produce a complex shape using less manufacturing methods. Uh, so these are the objectives. So after that, click on the list of experiment. So FDM anatomy of 3D printer machine we have. FDM stands for fusion deposition model. Okay, so here the aim of the experiment is given. Like basically in industry, what happens is before going for a mass production, they'll create one prototype, and if the and that prototype is need to be tested and validated, and if the prototype is okay, they can go for a further mass production. So that is one of the basic idea of 3D printer we have. Okay. So click on the theory part. So in theory part, it is clearly given like types of FDM 3D printers, and there are different 3D printers here. So yeah, it is an emerging and promising domain, the huge potential attention of researchers. So we have a different technologies like stereolithography and selective laser sintering and fusion deposition model and multi-jet fusion. So, and the types of FDM 3D printers, there is no hard and fast classification. But in basically we have three different types. That is Cartesian 3D printer. Here the movement is three mutually perpendicular axes, generally known as X and Y and Z axis. And also we have a polar 3D printer and delta 3D printers. So it has a different movement of coordinations. So once you understand the theory part, you can click on the pretest and you can answer the questions. So here the procedure part is given, like how we need to conduct the experiment. So read the procedure here thoroughly, then only you can proceed. Like we have like select the name of the 3D printer whose anatomy to be studied, and now click on the first option to know about the parts of the selected 3D printers. Images of different parts will be displayed on the screen along with the name of the part. Click on any part to know about its functions and more details. Also we have assembly part, like different parts will be shown on the half of the screen. Click on the parts in the sequence in which they are shown. And if the wrong part is selected, there will be a message like pop-up message will be displayed with the name of the parts to be selected. If the right part is selected, then the parts will be visible on the other half of the screen. Okay, these are the procedures. So let us understand the simulation. So as you can see, these are the different 3D printers eLab experiment we have. So let us understand the anatomy of Cartesian 3D printer. So here under the Cartesian 3D printer, we have two different experiments, that is part of the Cartesian 3D printers and assembly of Cartesian 3D printer. So if you click on that Cartesian 3D printer. So under the Cartesian 3D printers, we have different components of the 3D printers. Like we have frame, y-axis supporter, threaded rod. So if you click on any of the components, so you'll be get the in-depth details about that component. Like the frame. The frame is made up of aluminum and it is developed by casting process. This process is provided the main structural support and that is required for the printer. So in our lab, we have MakerBoard 3D 3D printing replicator plus we have. So there we are going to use PLA material, which stands for polylactic acid. So that is one of the cheap and affordable 3D material we have. So Yeah, under using its own software is there, MakerBoard 3D software is there, or AutoCAD or Fusion 360 software is there that you can design and you can print your own 3D objects. So, okay, so let us understand the other parts as well. So, y-axis support supports the smooth rod of that are responsible for the movement of the bed, and the threaded rod, the specification is given, and the threaded rods are coupled with the motor using the couplings. The nut is inserted in the x-axis assembly, which is moves up and down and carries the x-axis assembly. Okay, so bearing diameter of the bearing is 8 mm. These bearings guide the frame of feed bed on the y-axis. So like this, similarly, you can explore other parts as well. Why we use for fully all those things. The motor. All the specifications of the motor used in the y-axis assembly are same as the specifications of motors used in z-axis assembly. Okay, so the as you can see, we have a spool. Spool usually the material consists material is rolled over the spool. So we are having a material is PLA. PL stands for polylactic acid. So that will be rolled over here and it will be moved to the smart extruder. In that smart extruder, it will be melt that material and the layer by layer construction will happen. Okay. So okay, once you understood the parts of the 3D printer, there is one more experiment, that is assembly of a Cartesian 3D printer. So if you click on that, so there are three different assemblies we have: x-axis, y-axis, and z-axis. So you can click the any axis. So as you can see, there are different parts are given. So as per the procedure, make sure you follow the sequential order to assemble the 3D printer. Okay. So if you by default, by mistakenly, if you click on the second option, there will be a message, pop-up message like, please follow the sequence. So click on the smooth rod first. After that, bearing, as you can see on the left side of the screen. So assembly parts is going on. Click on the idler and extruder. And so this is how x-axis assembly looks. So click on the y-axis assemblies. So, axis assembly. So this is the y-axis assembly. Similarly, we have z-axis. So here the part is given. So you can click on the, you can complete the this one, complete the assembly. So let us look into the one more polar 3D printer we have. Again, the parts of the polar 3D printer is given. So you can explore by clicking the any of the component. So y-axis base is the base for the assembly of the polar printer. It is structural support. So this is one of the important parts of the 3D printer. Extruder is the core of any 3D printer. It heats up the filament of usually the material will be PLA and extrudes with the help of its nozzle. So the material will get melt over here at the nozzle and it will build the layer by layer construction will happen. So usually the layer will be 0.1 mm to 0.2 mm. If you want to print a higher precision, you can go for a 0.1 mm. So imagine if you want to print around 50 mm of object, above height of object, if the layer thickness is 0.2 mm, so if you divide by 50 divided by 0.2, you'll get the around 250 layers of that construction. Okay, so let us understand about the assembly of polar 3D printer. So then, okay, so this is how the finalized polar 3D printer looks like. So let us look into the one more 3D printer, that is Delta 3D printers. So if you want to print around like a cylindrical type of object, you can go for these kind of machines like Delta 3D printers. So here the different parts is given. Base is the main structural base or the base and support for the printer. Okay, so these parts you can explore. So let us directly dive into the assembly part of this Delta 3D printer. So assembly part of the Delta 3D printer is like this. So click on the base. After that, the base is connected with the holder and click on the rod. So base holder and upon that the rod is fixed. On the top of the rod, the top cover is going to fix. So on the top of the cover, we have a top cover frame. Click on that. So it will be get assembled. And the linear rail we have. Click on the motor, base, bed, and slide with connector. And this is the connecting rods. So these are the connecting rods which helps for the movement of the 3D printers. Click on the extruder, pins, okay, and LCD panel. So this will be the finalized Delta 3D printer looks like. So basically the main application of for the Delta 3D printers to create any kind of cylindrical shapes which has a which has a bit higher in the length compared to other objects. So these cylindrical objects you can easily build over this Delta 3D printers. So after that, you can explore the once you understood the simulation, you can explore the post test and you can test your knowledge. And also we have some references, and you can also free to share your feedback so that we can improve. Also, we have a different 3D printing equipments in our lab. So in that we can design the 3D objects and create our own design. So some of the complex geometrical shapes also that can be also easily built. We have a HP Jet Fusion 580 3D printer also we have. So yeah, that's all from. So any questions? Hello. Okay, so I'll hand over to Shrestha. Thank.
Thank you, Prithvi. Yeah, so that is what was the demonstrations on 3D printing fifth experiments. So I think with this, we can end the presentations from Virtual Labs team at NITK Surathkal. Now session is open for queries from the participants, if any. So we have demonstrated labs from different domains. We had already also seen session on VLab development and session on virtual reality. Hope the sessions were useful. So if you need to know any of the other labs and experiments, you can always explore the platform. So, and you can look into the procedure of any experiment to go through the simulation. In case if you find any issues even after following the procedure, then you can always contact our team at any point. We'll be always there to help you out. So with this, thank you. Handing the session back to the host. Thank you, sir.
Thank you, ma'am. We'll begin the participants. We'll have the valedictory session in a moment. After which we will have the feedback taken from you all, and the attendance link also will be posted during the valedictory section. So I request all of you to please stay online, and we will close this program with the valedictory session.
Hello, good afternoon.
Yes, sir, you're audible, sir. A very good afternoon to everyone. A warm welcome to this valedictory session of the 1 week online faculty development on harnessing virtual labs for effective student engagement, organized from 17th to 21st March 2025. So over the past week, we have had several insights on the virtual labs, right from the demonstration and overviews of multiple lab setups to the broader initiatives at NITK Surathkal, such as the digital and the transdisciplinary learning initiatives. Our esteemed speakers from NITK Surathkal, Professor Gangaram sir, Dr. Mervyn Thomas sir, Ms. Shrestha ma'am, all the other team. They have enlightened us on several other pilot projects involving remote triggered lab, virtual reality based labs, along with how we can actually create the virtual labs. So it has been a wonderful learning journey for all of us, I guess. I hope, and we believe that each one of you has gained a deeper understanding on the virtual labs and how you'll be able to effectively harness these labs for improving student engagement. We are very glad to have many participants who have joined in because of the limited number of the capacity of a Zoom meeting. We were not able to accommodate them, but there were people who are joining us from the online YouTube link. So I thank everyone for registering and being part of this session. And this afternoon, we are delighted to have with us Professor K. Sridhar sir, who is a senior faculty at Mechanical Engineering Department at Lendi Institute of Engineering and Technology. He is also the co-convener for this faculty development program. Along with him, we have Ms. Shrestha. She's from NITK Surathkal team, and she's the one who has been constantly in touch with us regarding to know how we can plan this session. So I thank ma'am for this time. It's a privilege to have our guest this morning. So, and without wasting much time, I would like to invite Ms. Shrestha ma'am to speak a few words and address the gathering.
Thank you, sir. So very good afternoon to one and all again. So myself, on behalf of Virtual Labs team, Outreach and Development team at NITK Surathkal, on behalf of Professor K.V. Gangadharan sir and Mervyn sir, would like to thank the entire management team of Lendi Institute and also Daniel sir for hosting this FDP on virtual labs for the faculty members and students of various colleges. So thank you. First of all, thank you, sir. And we are glad to see the response from the participants, the large crowd, and also active responses. So throughout the session, you were interacting with us. So all our team members are happy about it. So thank you all the participants for actively being in the session. So I hope the sessions were useful from the past 4 to 5 days, whatever we had. So as Daniel sir told, we had sessions, as you know, we had sessions on demonstrations, virtual labs, demonstrations of virtual labs in different domains, starting with IT, then followed by circuit domain, core domain branches. And today we had demonstrations on virtual lab development, session on virtual lab development, and also immersive learning through virtual reality. So hope the sessions were useful. As I told earlier, we showed few of the labs and few of the experiments from that. So I hope with that background, you all can explore the platform and utilize it. And you can follow the procedures to perform each of the experiment. And if you have any queries at any point, you can always get back to us. Our team will always be ready to help you out. And also for the colleges who are not part of virtual labs initiative, you are always invited to be part of the initiative. As told earlier, to be part of virtual labs initiative, there is no financial involved. Only thing is there is a form called expression of interest form that has to be filled. The scanned copy has to be mailed to us. So I'll again be putting the link of form in the chat box. That has to be downloaded. The filled scanned copy of filled form has to be mailed to our mail ID, that is solve@nitk.edu.in. So once you submit that form, we will onboard your institute, or your institute will be onboarded as nodal center for this virtual labs initiative under NITK Surathkal. Starting from there, we can have trainings on virtual labs, starting with faculty training, introductory faculty training we can have, and also we can have various levels of workshops and webinars under this virtual labs initiative. So there are many benefits for nodal centers. So Lendi Institute is also one of the active nodal center, which was active from many years. So this FDP was on behalf of that. So I once again invite all the institutes which are not part of virtual labs initiative till now. So I'm just sharing the link in the chat box. So details are provided over there. So that's it. So I once again thank Daniel sir and the organizers for this FDP and also the participants. Thank you, sir.
Thank you very much, ma'am. At this time, I invite our participants to share their feedback. I hope you have learned much from the FDP, and you have also learned what initiatives are there that you can actually learn from an NITK team so that you can implement them in your institutions. So I invite our participants. Before that, I thank ma'am for giving us the overview of what initiatives are there and how we can actually be a part of the NITK Surathkal team to take for this project forward. Thank you, ma'am, for that.
Thank you, sir.
Thank you. Yes, now we'll be hearing from the participants. I invite you all to please unmute yourself and you can give your feedback on the FDP experience. What went well and what could be improved and any suggestions for the future programs. Constructive criticism is also welcome. So it helps us refine our efforts. So I invite, the meeting is open to all. You can unmute yourself and we have given the option to unmute yourself. And I request you all to unmute yourself and give a feedback on the FDP.
So,
Yes, sir.
excellent. It is a very good exposure to online experimentation system. Very nicely delivered. Thanks to speakers and organizers.
Thank you for the feedback, sir. Thank you. Anybody else who want to share?
Good afternoon to all.
Good afternoon, sir.
It's a very nice session. I thank the Lendi Institute of Technology for organizing such a workshop. Yesterday, I demonstrated my students also. They have done the experiment on performance of the hydraulic machinery, that is Pelton wheel. Everyone learned that how to do the experiment, and they are feel like that they have done the experiment actually. I thank organizer for organizing such a wonderful workshop for the faculty, and this will definitely helpful to all the faculty and the student also. Thank you very much.
Thank you, Satish sir, for your feedback. Yes, the main idea is to give the students an overview on how an experiential learning for them. So I'm glad that you have already implemented that in your institution. So thank you, sir. Thank you for the feedback. So we have Mr. Dawal A. Patel, sir. Sir, yes, sir, you can unmute yourself and you can talk. Dawal, sir. Or,
Sir,
meanwhile, anybody else what?
Daniel sir,
Yes, sir.
good afternoon sir.
Yes, sir. Good afternoon, sir. Sanyas, sir.
This is Sanyasra from Vijnana Institute of Information Technology, Visakhapatnam. First of all, I would like to thank you for the wonderful FDP, sir. It was a great opportunity for all the students and faculty. And also thanks for the resource persons from the NIT Sreshta. It's a wonderful FDP. Thank you so much, sir, once again. Hi, sir.
Thank you very much, sir. Thank you for your feedback.
Sir.
Anybody
Hello.
else? Yes, sir.
Sir, it's Vamsi Krishna from Baba Institute of Technology Science, sir. It's
Yes,
a wonderful session, sir. I hope that other sessions will be conducted, sir, like this.
Yes, sir. Yes, sir. Thank you so much, sir. Thank you. Anybody else who want to share? Otherwise, we move on to the next part of our program. Thank you all for your feedback. We appreciate your feedback, and definitely, we, like sir said, Krishna sir said, we will have more of these kind of sessions in the upcoming days, so that the student would be benefited from that. Thank you everybody for the feedback. Now to formally conclude this program, may I invite Professor K. Sridhar sir, Senior Faculty of Mechanical Engineering Department, and also the co-convener for this FDP. I would like to kindly invite him to deliver the vote of thanks, after which we will have a few announcements, and we will close with the national anthem. Over to Sridhar sir.
Good noon to all of you. Dear faculty members, delegates, and distinguished guests, and committee members of this program. Greetings from the Department of Mechanical Engineering, Learning Institute of Engineering and Technology. On behalf of the organizing committee, I would like to express my appreciation and thanks to all the participants of this 1 week faculty development program on harnessing virtual labs for effective student engagement, which was held during 17th to 21st March 2025. It has been our pleasure to host all the participants of this faculty development program through online Zoom platform. The participants were very enthusiastic and showing keen interest towards this program. I am thankful to all the participants for joining from different parts of the country. We have been fortunate to have some of the eminent persons from academia working in the area of virtual labs. I am sure that the participants must have benefited by attending this program. I am very much thankful to the management of the Learning Institute of Engineering and Technology for funding this faculty development program. Without their generous financial support, it would not be possible to organize this event. My sincere thanks to the Honorable Chairman, Sir, Sri Masudan Rao Garu, Honorable Vice Chairman, Sri Srinivas Rao Garu, Honorable Secretary, Sri K. Sivaram Krishna Garu, for their constant encouragement throughout this event. I am very much thankful to the Principal of Learning Institute of Engineering and Technology, Dr. V.V. Ramareddy Garu, for continuous support and advice, which have greatly helped towards the successful organizing of this faculty development program. I sincerely thank our chief guest and section speaker for the first day, Professor K.V. Gangadharan, sir, participating institute coordinator, virtual labs, for kindly accepting the invitation and gracing this inaugural function. I am very thankful to the views given by Mrs. Sreshta ma'am. Thank you very much, ma'am, for sharing your valuable thoughts. I am also thankful to organizing team, NIT Karnataka Surathkal team, participating Institute Coordinator, Professor K.V. Gangadharan sir, Institute Development Coordinator, Dr. Prithviraj Umesh sir, Institute Integrated Coordinator, Dr. Mohit Sahiliani sir, Institute Outreach Coordinator, Dr. Mervin J. Thomas sir. Special thanks to all the other resource persons, Mrs. Sreshta ma'am, Mrs. Vismaya ma'am, Mrs. Akshaya Acharya ma'am, Dr. Vaishali ma'am, Mrs. Ashita Pai Sam, Ms. Anusha Salian Sam, and Mr. Sumant Varun, and Mr. Rutvik from Virtual Labs team, NIT Karnataka Surathkal. Thank you very much, madam and sir. I acknowledge the unwavering support received from the faculty and staff members. My thanks also go to all the people who have given their precious time to make this event memorable. The Virtual Labs Nodal Coordinator, Mr. Daniel Silas Kumar, the organizing team, in particular Mr. Gangadhar, Mr. Jagdish, Mr. Kameshwar, sir, Mr. Anil Kumar, Mr. Appanna, and also to the co-convener, Mr. KCH Sekhar sir. Finally, I would like to thank all the participants who have given their valuable feedback today related to their experience of the program. We will definitely take your feedback and improve for the next program for further improvement. Thank you very much for giving your valuable feedback. The response for this faculty development program is tremendous, and we are sure that we will be organizing the next one very soon. This time in an even better way, taking into consideration feedback of all the faculty as well as the keynote speakers and organizers. I once again thank everyone whose contribution has made this faculty development program on virtual labs a successful one. Thank you very much.
Thank you, sir. Thank you very much for the vote of thanks. We have a quick announcements before we conclude. The link for the feedback is posted. Overall feedback is posted in the chat box right now. I request all of you all to fill this form. This will be considered for your attendance as well. Please make note that the certificates will be issued only to the participants who met the attendance criteria and all those and fill the feedback links. And the certificates and the recorded lectures will be shared during the second week of April. Please note that the certificates and the recorded lectures will be shared during the second week of April. I request all of you all to kindly be patient with us. We will be sending it to you all during the second week of April. Once again, thank you all for your active participation throughout this FDP. All the participants were, some of them were really enthusiastic. They even implemented in the institute after your after learning from this past week. So thank you. We trust that you have found these sessions valuable and you will be using them for the benefit of the students. Now, as we play the national anthem, may I request if we are in your places to please stand up, and we will close with the national anthem. As I play the national anthem, I request all of you to stand up in your places. Shall we last time?
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा यमुना गङ्गा उच्चल जलधितरङ्गा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Jai Hind. Once again, thank you all the participants for joining us this evening. With this, this afternoon, we conclude the 1 week online faculty development program on harnessing virtual labs for effective student engagement. And on behalf of the organizers, resource persons, and the participants, we extend our heartfelt gratitude. Thank you for joining us, and we hope to see in the future events as well. Stay safe, take care, and have a great day. Daniel signing off. Thank you very much. Thank you, ma'am. Thank you, NIT team, for
Thank you, sir.
the sessions. Thank you.
Good afternoon, and thank you to all of.
Thank you, sir. Thank you. Dear participants, please note that the feedback link has been posted in the chat box. I request all of you all to fill the feedback link. We've also posted it in the YouTube link as well. YouTube chat box. Thank you, everybody.